So the symbol for population mean is going to be this guy. It's called the Greek letter mu, spelled this way. Okay, so basically all it is an average, just like you've always done. So you divide by the number of terms, n, times every single term from 1 to n. So in the stats books, they write it really officially, just like this. So this capital sigma right here, all that means is sum. I'm sure you've seen this in college algebra or in statistics. So whenever you see this capital Greek sigma, it means sum or summation. Okay. N is the total population. So just the number or the number of elements. Xi is just a specific data point, some data point or element. Okay, so if you were to use the formula to make it more official, all you would do, so let's say we went to this example here, find the population mean. So since they use the word population and not sample, you're going to say mu is equal to 1 over n, which is 1, 2, 3, 4, 5 terms, so 5 times the summation from I equals 1 to 5 of some x data point, which is basically stuff we've done before. 1/5 times 5 plus 10 plus 20 plus 40 plus 80. Okay. Now, adding these guys up together, that would be 120, 140, 150, 155 divided by 5. What is that going to be? $120, 60. Oops, sorry, I think I messed that up. 120, 140, 155, yeah. So it'd be 155 over 5. There we go. So just simply divide that and we'll know what it is. Should be, let me think. Yeah, I think it's 31. Okay. Anyway, I don't want to spend too much time on that because I am 90% sure all of you know how to do an average. And we're going to talk about that on Excel pretty soon. The next thing is idea of minimum and maximum. So in stat books or in commands in Excel, if they say min of a list, that'll be the smallest value in the population or in the collection of data points. Maximum will be max, of course, largest value in population. Median is a little bit different. This one I'm going to show you how to find because it's not as obvious. Of course, you can all point out which is the biggest or smallest, but median is the centermost value of the population. You have to put this in sequential order though. So if it's not in order, this is not gonna, you cannot find the median. Also, there's two different ways to do it depending if you have an odd number of data points versus an even. Okay, so if you have an odd number, well then you just pick the one in the middle and you're done. If they are in order, numerical order. If you have an even number of data points, then you just pick the center two and average them. So let's do these examples really quick. Let's find the median for this list, 5, 10, 20, 40, 80. Same list as before. we have 1, 2, 3, 4, 5 elements, right? Since it's odd, you can see the one in the middle, right? Median is 20 because it's odd. Now, here we remove the last two terms, 5, 10, and added 15, right? So it's a little bit different. 5, 10, 15, 20. There's 4, so it's even. So what you have to do is take these middle two and average them. So the median will equal 10 plus 15 over 2. So that would be what, 25 over 2? Which would be 25 over 2, 12.5. But there is commands in Excel to find this for you. Especially if you have a long list, it would be annoying to put them in order. You'd have to use like a graphing calculator or Excel or something else. Okay. Anyway, you guys have any questions on finding the median or in either example? All right, let's move on to variance and standard deviation. Variance is really hard to visualize because we all understand an average, right? Variance and standard deviation is a little bit different, but the beauty of variance is that you can measure how spread out your data is. So for example, let's say you had two data sets, right? Two lists of numbers that had the same average, but one list had numbers all over the place, and another list had them all kind of close together. They could theoretically both have the same average. So because of that, you want to look at variance to see what exactly are the points doing. So variance is going to be a measure of how scattered or spread out the data is from the mean. It's also going to be squared, so they take basically they find the average squared distance from every single data point from the average. That's how they do it. That's how they develop this formula here. Standard deviation is they square root this squared value because they want a non-squared number. They want the actual distance. That's why they made this one. So then you start thinking about, okay, what does standard deviation mean, right? So, or why do we care is another question people ask. Like, for example, let's say you have to be at work at 8 p.m. every day, right? And you're like, you know what? On average, I'm there on time every single day. But if you arrive at, let's say one day you arrive at 9 and another day you arrive at 7, then yeah, on average, you're there at 8, but you're kind of all over the place, right? So you can you can look at the standard deviation to see, okay, how far away is he? If I collect every single time he signed in when you got to work, or this person, right? On how far away was he from being there at 8 o'clock? Because average doesn't really tell you, because we can all be on time on average, but in reality, I might be getting there at 8:30, 7:30, 8:30, 7:45, 8:10, or 8:10, 8:15. And at the end of the day, it appears that I'm on time. But standard deviation shows you how far from on time am I on average. Okay, so these again are for populations. So a population means you have like the entire data set. Where a sample would be literally what it means, right? Like a sample of the population. So for example, let's say I want to answer a question about everyone in San Antonio. If I got every single person in San Antonio to, like, let's say, tell me what kind of ice cream they like or whatever, right? Or how tall they are, then I'll have a data set of an entire population. Now, if I take a sample and I say, I'm going to pick at random people who live in San Antonio, and find out how tall they are, I'll have a sample average. So that's the difference. So these formulas are going to be for population. The formula for mean on sample and population doesn't matter. It's going to be the same formula. But anyway, so let's go ahead and do it by hand just for fun one time. Okay, so variance, let's find the variance and standard deviation for this example here. So I went ahead and gave you the mean because we did that earlier. And the formula requires the mean, the mu right here. So to find the standard deviation, you need to know n, and you need to write down every single value. So here we go. So we have 5 elements times the sum of I equal to 1 to n, which is 5, of the absolute value of the mean minus every single data point. So that would look like this. Oops, squared. So that would be 1/5, put big brackets here, of 31 minus 5 plus 31 minus 10 plus 31 minus 20, all the way to my last data point. There we go. So just add these all up. Let me simplify this because right now it looks kind of ugly. 31 minus 5, that's going to be, what is that, 26 squared plus 21 squared plus 11 squared plus negative 11 squared plus 31 minus 80, that would be what? Negative 49, I believe. Yeah, that's right. So then you just square them and add them together. At this point, I think I might need a calculator. Yeah, let me go grab it. 1 second. Okay. So at the end, I'm going to divide by 5, right? Just remember that. So 26 squared plus 21 squared plus 11 squared plus negative 11. Here you got to put parentheses because you're squaring the whole thing. Plus negative 49 squared. Divide by 5. So this is our variance.
Sir, on the negative 11, it's supposed to be negative 9. 31 minus 40 is negative 9.
31. Yeah, you're right. This guy. Thanks. Let me fix that. So let me go back. Okay. So 744. All right. So that's our variance. So this is variance. Now, if you want the standard deviation, right? So standard deviation is just the square root of this. Be square root of 744. Which is about 27.28. Okay. Anyway, so it's the main idea is I don't want to go too deep into the concepts, but I just want you to remember what does mean, variance, standard deviation, what do they mean, and how do you find them? Okay, so let's go play with this in Excel now. Where is that thing? Oh, here we go. Okay, so you're just some random numbers, the width of a nut. Okay, there's about 100 measurements here. So we'll put the average right here. Oops. We'll put standard. Actually, let's do median, and then variance and standard deviation. I'll make that a little shorter. All right, so the commands are pretty easy. Just type equals to call your functions, right? I'm sure we might have mentioned this already. Choose average and then go select all the values. So that'll be 100 values. So that is the average of this population here. Median. Select 100 of them, so you don't have to go looking for the middle term. It'll find it for us. Now, variance, you need to pick the correct one. See how we have VARP and VARS. So you want to use the population one because we're doing population. The formula for sample variance is different. So I only gave you the one for population. Okay, standard. Here it is, STDEV. Select everything again. And there we go. Let's just make a note right here. This is pop or P. Anyway, alrighty, you guys have any questions about the intros, little intro to stat stuff? Okay. So let me share what I want you to do before the weekend ends. So you have a histogram homework. So I'm hoping you watched this video already. That's due tonight, but I'll go ahead and move that since I had some issues logging on last time. Statistical. We talked about this one today, so homework 11 should be based on what we just did. This one I want you to watch on your own and try to get it done. I have not changed the date yet, but I want you to have your exam finished by Wednesday. So it'd be good to have all this out of the way by this weekend. That way, on Monday we just do the review, and then you just take your test whenever. I mean, if you take your test sooner, that's fine too. Okay. The projects, I'm still thinking about it. I went ahead and opened it, but I haven't decided how I'm going to do it just yet. Um, but I'll send an email about this very soon. If not, we'll talk about it Monday. It's just don't want to make it too complicated, and I don't want to, because we're running low on time already. We have about 2 weeks, I guess, after this one. But anyway, you guys have any questions so far? Okay. Okay. All right, guys. That's about it for lecture stuff. Do you guys have any? If you have any questions about your homework or any issues, please let me know. Otherwise, you're welcome to head out. I'll stay here till 5:50 if you have some questions.